Hey ladies, this is 4.2, Graph Quadratic Functions in Vertex Form. This is Miss Fitzgerald and Miss Tempo. Very good. Vertex Form, unlike yesterday's standard form, which was y equals ax squared plus bx plus c, is y equals a times a quantity, x minus h squared plus k. Where our vertex, we can look at it, instead of using the formula from yesterday, is going to be h, comma, k. What do we notice about the h's?
It's the opposite sign from what's in the equation. So here we have minus, but here we choose the plus.
Good job. Alright, so let's not label this. Another thing that we can also note here is that the axis of symmetry x is equal to h.
And if we look at the graph, remember the axis of symmetry divides the graph into two equal pieces.
Good job. Let's do some graphing, shall we, Miss Bontempo?
Okay, so let's look at the equation y is equal to negative 1/4 times the quantity x plus 2 squared plus 1. What's the vertex of this equation?
Well, Miss Bontempo, the vertex would be, we know that it's hk, so if I rewrite the formula on top, it's a times x minus h squared plus k. So my h would be negative 2 because you told me I have to switch the signs. And my k would be 1. So my vertex is negative 2, 1. Should we graph that first?
Yeah, let's go ahead and graph that.
Alright, negative 1, 2, and 1. A little bit easier than yesterday, wouldn't you say?
Yes.
Yes. I also know that my axis of symmetry is x equals negative 2 because that's what the x value is. Let's draw that.
Okay, so let's put it in with a dash line to show where the axis of symmetry is.
Thank you very much, Miss Bontempo. Another thing, why don't we label the vertex now so we don't forget to do it later?
Okay, so negative 2, 1.
Very good, thank you. So in order to have a good parabola, we need 5 points total. So we have 1. How about the other 2? Well, here's the vertex. I want to pick 2 points that are kind of close to it. So I'm thinking negative 1 and 0, everybody's favorite number. Sounds good?
Sounds great.
Good. So let's plug in each value and see what we get. Ooh, Miss Bontempo, I'm changing my mind right now as we speak. Do you know why?
Well, no, I don't know.
I'll tell you, and I'll tell our classes as well. I'm looking at this equation, and I'm seeing that there's a fraction. I'm also thinking 0 is a great number. I love it to death. But 1, negative 1 rather, would give me a fraction I still have to deal with here. So instead, what do you think I might use?
Maybe we should find a number that will nicely multiply with the 1/4. So maybe we want a number like 2.
Looks good to me. Okay, so if you're right, then that should work out pretty easily. So I have y equals negative 1/4 times, there's my negative sign, don't worry, 2 plus 2 squared plus 1. Go ahead, check my work. I have negative 1/4 times 2 plus 2 is 4, Miss Bontempo, and 4 squared is
16.
got it, plus 1. I'm looking at negative 4 plus 1.
I see negative 3.
Which equals negative 3. Delightful. So, let's go ahead and graph that point.
So 2 over and then down 3. 1, 2, 3, right here.
Hey, since you did that point, I know that I could also reflect it. So that's 1, 2, 3, 1, 2, 3, 4 from the axis of symmetry. So another point at the same distance would be 1, 2, 3, 4. We now have 3 of the 5 points that we needed. We need one more, so let's plug in 0. Y equals negative 1/4 times 0 plus 2 squared plus 1. Negative 1/4 times 2 squared is 4. Thank you very much. Plus 1. Negative 1/4 of 4, Miss Bontempo,
is negative 1 plus 1 is 0. Oh, 0, 0.
That's
That doesn't seem right. What did we do wrong? Oh, we didn't do anything wrong because we graphed the vertex wrong.
good catch. The vertex.
Is up here. So right here is our point 0, 0. And we know the other points reflected 2 across from the axis of symmetry.
Got it.
Okay, So all is left to do is we need to connect our parabola, our points, and look, we have a parabola that's facing downward. So what we also noticed is that our parabola is facing downward. So since it's facing downward, when we look at A, we notice it's negative. If A is negative, it means that the parabola is facing downward, and if A is positive, it's going to be facing up.
Yep. So we have another one. Let's disregard the numbering because obviously 2 comes after 1, which would have been the first problem. But we're going to call this number 1 anyways and pretend. First thing we need is what, Miss Bontempo?
We want to find what the vertex
We
is.
do want to find what the vertex is. So we know our vertex form is a times x minus h squared plus k. So my h would be?
Negative 5, 0, because there's no value for k.
Very good. That would be my vertex. So 1, 2, 3, 4, 5, 0. I think it's right this time. No mistakes.
I think it's good.
And the axis of symmetry would be x equals
Negative 5.
negative 5.
So let's fill it in.
Good job. And I'll go ahead and label this. What do you think? Will this open up or down, Miss Bontempo?
I think it's going to open up because A is positive 1.
Very good. Love it. Okay, so we said that we needed 5 points for our problem, so that means we need 2 more. Let's not go too far away from the vertex. So how about negative 4 and negative 3? Plugging each of these into your equation, you'll get y is equal to negative 4 plus 5 squared. Negative 4 plus 5 is 1. 1 squared is 1. Thank you very much. And negative 3 as well would be negative 3 plus 5 squared, which gives me 2 squared, which would be 4. Alright, you want to graph this for us?
Okay, so the first point is negative 4, 1, which is right here. Remember, we can reflect, so if we move over 1 the other way, we have the point right here too. And then the other one is negative 3, 1, 2, 3, 4, 1, 2, 3, 4 up here. And then if we reflected over our axis of symmetry, the point's going to be here. We connect it, and we have our parabola that's facing upward.
Good deal. And I'm just going to extend this out just a little bit so that we don't lose any points for not covering our graph. Thank you so much, Miss Button.
You're welcome.
All right. Oh, I did the next one. So that, ladies, was graphing in vertex form. Next thing we're going to show you is graphing in intercept form, which is not on this slide, but it's on this slide. So intercept form, y equals a times x minus p times x minus q. This one people love because now we're going to get 2 coordinates just from looking at the equation. So p would be our one of our x-intercepts, and q would be our others. But here's the thing to notice. We also have to switch the sign yet again, just like we had to do with the h. In order to find the axis of symmetry now, we have another formula for you to memorize. X equals P plus Q over 2. Same rules apply for the A. Shall we graph?
Yes, let's graph.
Alright, so let's find our P and our Q for number 4. What would my P be, Miss Bontempo?
Your P would be negative 1 because it's a positive x plus 1.
And the Q?
Is going to be positive 3.
Alright, so I like to write these as coordinates. So this would be negative 1, 0 for the first x-intercept and 3, 0 for the second one. Alright, let's go ahead and graph that. Negative 1, 0 and 1, 2, 3, 0 as well. Now, we also had a formula for the axis of symmetry. That was x equals P plus Q over 2. So, negative 1 plus 3 over 2, which gives me 2 over 2, which is 1. Axis of symmetry
Is going to be right here. X is equal to 1.
So I need to figure out what my vertex is now as well. So I'm going to plug in x equals 1 to my original equation, except instead of x, I'm going to write 1 plus 1 times 1 minus 3. So I get 2 times negative 2. I'm looking at negative 4. So my coordinate of my vertex will be 1, negative 4.
Wait, let me plot that. So we do 1, and then we go down 4, 1, 2, 3, 4.
vertex.
So they're right here.
Yep, and it is opening up, which we could have seen because the A is positive yet again. We said we needed 5 points, and now we have 3. How about one more? What's another point that's kind of close to the vertex? I mean, the axis symmetry.
I would choose x is equal to 0, because that's my favorite number.
I love it as well. So y equals 0 plus 1 times 0 minus 3. Now, a lot of this work you can do in your head. We're just showing it just to make sure that we don't lose anyone in this video. So I'm looking at 0 comma negative 3.
So right here.
Very good.
And remember, we need to reflect it, so if we move over on the other side, it's going to be right there.
Very good. Let's connect it.
Oh, and we have to go past the graph because we can't lose all our points.
Thank you very much. Only thing left to do is label the vertex, Sally.
Okay, so our vertex we said was 1, negative 4. There it is.
Wonderful. Okay, here comes the next one. Here's what we'd like for you to do. Try number 5 the same way that we did number 4. Use your notes as a guide. Pause now and unpause when you're finished. Alright, good job, Miss Bontempo. Hopefully you really did pause it and you did your work. Most of you probably found that x was equal to 1/2, and then you plugged it in, probably using your calculator, but that's fine. You would have gotten 12.5 for the y part of it. So your vertex was 1/2, 12.5. Check your work with hours. You can pause if you need to. Our intercepts were negative 2 and 3, so we graphed those. It's going down, of course, because A is negative. The other extra point that I found was for negative 1, and when I plugged it in, I got 8. So if you are off by just a little bit of a sign, go ahead and make that correction now. Otherwise, go ahead and move on. Hey, Ms. Bontempo, what's going on next?
What we're going to do is we're going to write the quadratic function in standard form. We see it was in our intercept form, so to write it in standard form, all we need to do is multiply it out.
Yep.
Okay, so let's go ahead and multiply it out.
So remember, we could use our FOIL method or we could use distribution. I'll use FOIL. So we multiply the first together, so it's x squared. First outer is x times 5 plus 5x. Inner is 4 times x, which is 4x. And then the last is 4 times 5, which is 20. If we simplify this, we get x squared plus 9x plus 20. So we have y is equal to x squared plus 9x plus 20.
Looks good to me. Standard form, y equals ax squared plus bx plus c. So, following your lead, I'm going to also do the same thing, but number 7 looks a little bit different. Good thing for me, and probably some of you, that I know the special product for this one. So, x minus 1 squared is going to equal x squared minus 2x plus 1, and then plus 7 at the end. That's a special product. Don't forget it, because I need you to know it. Then I'm going to distribute the 3 to all 3 terms, so I'll get 3x squared minus 2x plus 3, and then I'm going to add that 7 at the end. Now I will combine like terms, and I get 3x squared minus 2x plus 10 is equal to g of x, which is just function notation, which is the same thing as kind of saying for y. And that is in standard form. One quick reminder, from the special product for those of you that it's better, 5a minus b, and I'm squaring it. That will be equal to a squared minus 2ab plus b squared. One of the 3 that you should definitely memorize. Wouldn't you say, Ms. Bontempo?
I agree.
Thank you so much. Well, ladies, that's it for us. Thank you so much for joining us. You have a great night, and we'll see you back in class.
Bye.